Psalm 147, 2 through 6. The Lord builds up Jerusalem. He gathers together the outcasts of Israel. He heals the brokenhearted and binds up their wounds. He counts the number of the stars. He calls them all by name. Great is our Lord, and mighty in power. His understanding is infinite. The Lord lifts up the humble. He casts the wicked to the ground. The message this morning is entitled, The James Webb Telescope, A Grain of Sand and Your Problems. The James Webb Telescope, A Grain of Sand and Your Problems. It's typically good practice to have an attention-getting introduction at the outset of a message. You know, you always want to draw people in and try and get their attention so they'll pay attention to you. But in this case, I'm not going to have a special introduction. I'm just going to count on the title of this sermon to sort of grab your attention. What on earth do the James Webb Telescope, a grain of sand, and my problems have in common? And how on earth does all of this connect to the verses we just read from the Psalms? While you wrestle with that little mystery, let me talk with you a moment about the James Webb Telescope. You may have seen this in the news. This telescope has been in the news constantly the last couple of weeks. The telescope itself is named after James Webb, who's the administrator of NASA from 1961 to 1968. That was during the mission to get to the moon. We had the Mercury program, the Gemini program, and the Apollo program. This is an artist's rendering of this. It's quite a beautiful piece of technology. What it might look like in space. You can see the gold-plated, mirror-shaped hexagon mirrors there in that piece of the image. And then you can see here also the sun shield on the backside of it, which is trying to regulate its temperature. Looks like a big piece of aluminum foil, doesn't it? Just spread out on the back of it. It looks like a sail, but it's really not a sail. Here is another picture of it. When they were putting it together, NASA took this picture. Isn't that beautiful? Looks a little bit like a honeycomb, doesn't it? I wonder if they took some of their inspiration from God's creation there. It's partially assembled here. You can see the gold mirrors clearly here. You can also get a sense of the size of the telescope. If you look down at the bottom of the image, you can see the size of a human being compared to the telescope. What a great achievement of mankind to make something so amazing. And the unique thing about this over the Hubble telescope is the Hubble telescope orbits the Earth. But the Webb telescope orbits the sun. It's about 1 million miles from the Earth, and it orbits the sun. So that's a unique feature. It's a little bit farther out and allows us to get greater images. This here is an image they call the deep field image, and this is really the one that's attracted all of the attention, among a few others that I'll show you. This is the first set of images that Webb has produced, and it's called a deep field image. And the reason it's called a deep field image is because when a telescope looks out into the universe and it's trying to take images, sometimes what they'll do is they'll leave the aperture, they'll basically leave it open and take the picture for a very long period of time. And the idea is we can get the most faintest objects that are back there if we leave the exposure open. So they left this one open for 12 and a half hours. So this picture is 12 and a half hours of just staring at this one place in space. This image is called Galaxy Cluster SMACS 0723. Now, there won't be a test afterwards, so you don't have to worry about that. I'm just going to call it SMACS, all right? I don't know if they call it SMACS or not, but I'm not going to stand here all morning and say SMACS 0723. This is the SMACS image, and this is the deep field image. Now, scientists suggest that there are thousands of galaxies in this one image. Not stars, but thousands of galaxies in this one image. And many billions of stars. Let's take a few moments and let's drill into a couple of spots here and let's look more closely at this deep field image. First of all, let's look at this section right here. This section. Let's take a look and see if we can get that to show up here. And that is what is in that section of this image. Now let's try and notice a couple of things here. The bright images here, let's see if we can get this to work properly. You see those? Those would be very bright stars that shine out from one central point. That would be a star. But then these things like this, that's a galaxy, 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 and so on. I'm being repetitious. Why? Look at all the galaxies. Amazing. All those galaxies. Numerous galaxies and some extremely bright stars. Let's go on now. Let's look at another section. Let's look at this section sort of in the middle here. Now I want you to notice something. I'm going to go back here. Do you notice kind of around the center, do you notice these things that look like they're not formed right? They look like they're distorted, like you took an image and tried to wrap it around a baseball or something? Well, we're going to see that in this image here a little bit more clearly. You see it right here. You see it right down there. You see it to an extent right there. All right? What that is, those are galaxies that are in the far background of smacks. And so what happens is you've got these galaxies, smacks right here, but behind them you have other galaxies. And what happens is because of the gravitational power of smacks, the light coming from behind it is bent and twisted and distorted as it comes to us. That's why you see those. It looks like somebody smeared it on a paint. Just went like that. All right? That's why you're seeing that. Those aren't actually shaped like that. But let's look at this. Look at that spiral galaxy right there. Got those nice arms on it. Here's a red one. We have red here. We have stars like right there. We have another spiral galaxy right there. Amazing. Down here is another galaxy. That's pretty cool stuff, isn't it? All of those in this one image. Let's go on now and let's look at another section. This will be the last section of this image that we look at. Now we can start to see some galaxies a little bit more clearly, can't we? We see one right here. Isn't that beautiful? We see them, two of them right there. We see one there that's almost like a disk. All of those galaxies. What a sight we have here into the far reaches of space. The telescope took some more specific images also, more direct specific images. Here is what is known as the Southern Ring Nebula. Now a nebula is a gas area, a gas cloud in space. That's what a nebula is. We can zoom in on this a little bit here and see it a little bit more clearly. Stunning, isn't it? Stunning, isn't it? And then finally we'll look at something called Stefan's Quintet. Stefan's Quintet. And this is a picture of 5 galaxies that appear to be very close to one another in the sky. But they're not actually that close to one another, you know. But just from our perspective, they look close, very close. And this is visible in the constellation Pegasus, which is a horse kind of up on his legs. And it was discovered by Edward Stefan in 1877, and it is named after him, Stefan's Quintet. So we zoom in a little bit more here, and we see these amazing and beautiful galaxies. The heavens declare the glory of God, don't they? But the Webb telescope is not just making news because of its amazing pictures. That's part of it. It's also making news because of the story that is being told about what it has seen. Because of the Big Bang Theory and evolution, secular scientists, that's non-Christian, non-Bible-believing scientists, claim that these images of these galaxies are billions of years old, that what we're seeing are these galaxies many, many billions of years ago. Here are some of the headlines that I just pulled off the internet. This is one. Webb's first image reveals fine details of galaxies from billions of years ago. Here's another one from a station in Jacksonville. This is what the universe looked like over 13 billion years ago. It's everywhere. And then finally, here's one. The James Webb Space Telescope is like a cosmic time machine. Here's why. So we have this idea that's being presented that what we're seeing in these distant galaxies is actually billions of years ago. And this is what we call a light travel time problem. Light travel time problem. Essentially what they're saying is that because light travels at a certain speed, and we estimate these objects to be a certain distance away, the light from them must have been emitted billions of years ago. This is a light travel time issue, a calculation of time given distance. What's the problem with this? Let me show you an illustration here to kind of help you see how this works. All right, so here we have this distant star, and you know this is very accurate here. This is exactly what a star looks like out in space. If you got close enough, you would see it. But there's a star out in space, and then we have the Earth over here, and the star is way, way off. The star is an incredible distance from the Earth. And so what we have here is we know that light travels at a certain speed, or at least that's what we've measured here on the Earth. So the idea is that the light was emitted way, 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 way back a long time ago, and it has to travel through space and eventually get to us here. That is kind of the light travel time problem. It takes time for it to move, and so they've calculated this, and here's where the problem comes in. And keep in mind, this is a calculation. No one can go out there and measure these things. They're too far away. But the calculation is that the time that it took for this to travel from those stars out there, from SMACS, all the way to the Earth, is 13 billion years. But we have a real problem here, because from the Bible's standpoint, the universe has not existed for billions of years. And I had a slide in here, but I took it out for time's sake, where I'd show you how you can calculate when creation was, based on the genealogies in Genesis 5 and other places. But if you look at the Bible and if you analyze it, the Bible shows us that the earth was created about 6,000 years ago, the whole universe, including all the stars and the galaxies. So there is no possibility, if the Bible is right, that this calculation is right. 6,000 years according to the Bible. So here's the question for you, and we're going to get into a little bit of science, and we're going to dig a little deep here for a moment. I challenge you to stick with me, okay? Stick with me because it might be a little confusing, but I'll do my best to explain it to you. So how do Christians deal with this? If we're going to believe the Bible, how do we believe the Bible and believe that these galaxies are 13 billion years old? It's just very, very hard to do that without twisting and contorting the Bible till it's almost unrecognizable. Let's give you an answer to that question. Let me first point you to a place you can go look up this kind of thing and many other science Bible questions. Creation.com. I know I've mentioned that to you before. But if you go to creation.com and you look up starlight and time, you're going to get all kinds of articles and all kinds of answers to satisfy your curious intellectual mind. And this is where I'm going to get my answer from an article here on this site by a guy named Don Batten. So first of all, let me point out to you that the Big Bang has a light travel time problem too. So our problem is that when you look at how far away the galaxies are, and then you know what light travel is, you do the math and it's way too long. So we've got a problem there with the light traveling to us in the right amount of time to fit what the Bible says. And I'm going to give you one of the potential answers to that in a moment. But the Big Bang Theory, evolutionists have the same problem. It's just in a different form. They have a light travel time problem also. One other important quality of light, not only does light give us brightness so we can see, but light also takes heat with it. Light is the means by which that radiation of heat is transferred through the universe. Let me give you an example here. Let me try and illustrate this for you. Now, this is not a star. This would be one section of the universe, okay? Way off in the distance, there's this section of the universe represented by this star. And then over in another section of the universe, way, way, way off, we have another star. Well, what scientists have learned is that the temperature of the different areas in the universe are all roughly the same, very, very close to the same temperature. And this poses a problem. Light is what moves heat. So we've got this one area in the universe, and we've got another area in the universe. And if they're eventually going to get to the same temperature, then light has to travel between all of these different areas of the universe so the heat can be distributed. It'd be like cutting on your heater and having it coming out of one vent and being over in the far corner of the room. that heat has got to have the time to move and get over there. Well, in the universe, that heat is moved not by air, but by light. And so we've got this hot section of the universe, and over here we've got a cool section of the universe way, way apart. So we got to have a way for light to get over to the other side so that they'll all have the same rough temperature. And hopefully that makes a little bit of sense to you. But the problem is this. Light moves the heat, okay? And the temperature is the same on both of these, which implies that the light from one side had to get over to the other side and vice versa for those temperatures to level out. But here's the problem. The distances are too great for light to have traveled from this side of the universe to that side of the universe. So if we're going to have an equal temperature universe, we've got to have a way for light to get from one side to the other, but when we start doing the math, there's not enough time. You see? Same problem. Same problem. We've got a universe that has a same temperature, but we got no way to explain how the light got from one side to the other in that amount of time. Okay? There's not going to be a quiz on this. This is called the horizon problem. The reason I bring it up is to let you see that it's not just the Christian who believes the Bible that has a problem out in space with the light travel time thing. Those people who are writing those textbooks and telling you the Bible's wrong, they have the same problem. Now, they've come up with various ways to explain them. And I could go through and talk about those, and you can find those in these articles. But the point is, they have the problem. It's not just us that have to worry about this massive universe and how light gets around in it. They do too. So don't let them get on their high horse with you and make you feel like you're a bumbling fool because you believe the Bible. Because they've got the same problem too. All right? So how do we deal with this? How do Christians who believe in the Bible deal with this problem of time and light and the travel and the distance? According to Don Batten of Creation.com, God could have used a process called time dilation to cause starlight from the stars now way off to have reached the earth immediately, or by the time Adam and Eve were made on day 6. Stars were made on day 4, Adam and Eve on day 6. It's called time dilation. It's one of the theories, one of the ways God could have used to deal with this problem. So what is time dilation? You're like, oh man, don't turn me off now, okay? Because this is cool. This is really, really neat stuff. So hang with me. The first thing you got to understand about time, and this is going to blow your mind if you've ever never heard about this, is that time does not pass the same every place in the universe. Time actually ticks off the clock at different rates in different places. And we've actually been able to measure this. Time is not fixed for everyone everywhere. Let's go to Don Batten's article. He said, Einstein is famous for discovering that time is not constant, but is affected by movement, that's the speed that you're moving, and gravitational forces, that's the gravity of stars and planets and things like that. When an object moves very fast, time for that object slows down, or even stops at the speed of light. So Einstein's theory of relativity, general and special relativity, you've heard of Einstein, haven't you? The guy with the crazy hair? All right. He had this famous theory, and they've been able to test good parts of it, that suggested that as you go faster, time slows down for you. Let's go on, read a little bit more. Also, when an object is in the presence of a massive object, like a planet or a star or a galaxy, which provides a strong gravitational attraction, another pull, strong pull of gravity, time slows down. Has your head hurt yet? These effects are measurable and thus have been verified by experiment. Now this is the cool part here. So essentially what he's saying is, as you get closer to something with a lot of gravity, time slows down. And if you get away from that object with gravity, time speeds up. Also, if you go really, really fast, the faster you go, time slows down for you. And the slower you go, the time speeds up for you. All right. Let's talk about satellites for a moment. This is where we've actually tested this, and this is going to give you an even worse headache. You're going to want to watch Interstellar again 5 times to see if you can figure out how time works. All right, he goes on. They are so real. In other words, the effect of gravity and the effect of speed are so real that GPS satellites, which depend on precision clocks for global positioning calculations, must have their onboard clocks adjusted for the lesser gravity, being up in the sky, and for the speed of movement of the satellite. They have to actually adjust a satellite's clock because its clock is not reading the same in space as it is on the ground. Mushroom cloud. So because the satellite is farther away from the gravity of the Earth, and because it's going a zillion miles an hour, it's the time on the satellite is not the same time out in space as it is on the ground. All right. Now hold on. Stay with me. Stay with me. Now let's consider a very significant statement on what God is doing with space. Let's go to Psalm 104, verse 2. It says, "You cover yourself with light." This is God. "You cover yourself with light as with a garment. You stretch out the heavens like a curtain." You stretch out the heavens like a curtain. Now we know right now that the universe is still stretching out. It's slowly moving farther and farther apart. God says He stretched out the heavens. He took what was small and stretched it out. Now let's go on and let's see what Don Batten says about this. He sees some great meaning in this for this light travel time problem. Here's what he said. Try to imagine God stretching out the heavens on day 4 of creation week. So God creates the earth, He creates the atmosphere, He creates space, He creates galaxies and stars. And they are, and this is very, very simple, but they're this big when He makes them. Okay? But God wants them to stretch out. So at the end of day 4, He takes all that He made and He goes shoo, like that. He pulls all that mass of all those galaxies and all those stars, and He pulls them billions of light years apart. Imagine how fast things are moving when God takes His hands and stretches out an entire universe. Imagine the gravity changes of all the objects in space being pulled apart. Batten goes on. This would entail massive gravitational forces. Imagine all that stuff being pulled apart. And enormous differences in speeds, both of which would change the time out there compared to planet Earth. Because we're not moving, we're not stretching, the universe is being stretched out. He finishes. Thus, in one Earth day, day 4, an enormous amount of time could transpire out there, allowing ample time for the light to travel to Earth. Now, I know that's complicated. I know it's complex. And one of the weaknesses that we have in Christians as we argue, and one of the weaknesses that we allow our errors, we allow our enemies to get by with, is to want a simple explanation for a very complex subject. You see? You go and tell somebody this who doesn't believe, or maybe some of you are sitting there going, well, that's just too complicated. Well, this is God, for crying out loud. This is a universe with billions of galaxies and trillions of stars. And this is a problem people have wrestled with for hundreds of years, thousands of years. If there was a simple explanation, we'd already have it. God is a complex being with an incredibly complex universe. There is a greater intelligence at work here than I can possibly fathom. If the satellite's time is different from the time on the earth, I have no hope of understanding all that God has done in the universe. But there are other theories, there are other explanations. But I'm not going to go into those. I just want this to suffice right now to show you that there are answers to even the most complex questions in the world regarding the Bible and what we see out there in the cosmos and here on the ground. There are answers. You can give the Bible the benefit of the doubt, because I'll tell you, if you keep testing it and you go and get good answers, you'll realize it just simply cannot be broken. So Wes, that's the James Webb telescope. Wow, that was a long time. We're going to be here till 12:30. No, we're not. So what does all this have to do with a grain of sand? He says it's the James Webb telescope, a grain of sand, and my problems. What does this have to do with a grain of sand? Let's go back to SMACS. Take a wild guess as to how much of the night sky this massive cluster takes up. When the Webb telescope looked out into the cosmos and it said, well, let's take a picture of this area. How big was that area of the sky? You say, Wes, thousands of galaxies and billions of stars. It's got to be at least half the night sky. Nope, not half. Well, it's got to be a quarter of the night sky. No, not a quarter. It's got to be at least a 55-inch TV. No. All that you see here, all these thousands of galaxies, all these billions of stars, are a point in space the size of a grain of sand. Let's go to the NASA website. This slice of the vast universe is about the size of a grain of sand held at arm's length by someone on the ground. Now, this whole week I've been looking around for grains of sand. My wife suggested that a preacher go over to Lowe's, because we don't have any sand around. She said, go over to Lowe's and go over to where they have the sand, and there's going to be some on the ground. Just grab some. I said, woman, you want me to go steal sand to teach about the holy God of the universe? It's a good idea. So I just got some along the side of the road. I figured the Department of Transportation won't miss it. So I got this grain of sand, and my idea was I was going to take some tweezers that we have in the house, and I was going to take that grain of sand, I was going to put it in the tweezers, because you really can't hold a grain of sand very easily. So I put it in there. My idea was to squeeze down on it and tape it so that I could lift up that thing and show you, look, this is a grain of sand. But it was so small I could not get it to stay in the tweezers. So you're just going to have to imagine with me a grain of sand held out this far, and that's the dot in space that all of this is contained within. Now, Silas told me, he said, Dad, you're not going to cry when you start talking about the universe, are you? I said, no, I'm not, but I'm feeling like I am. Because how many grains of sand are there in 360 degrees around and 360 degrees that way? How many grains of sand would be in that? I don't know. Quadrillions, septillions. It's probably incalculable. And every one of them has thousands of galaxies and billions of stars. Look at this is where we get to our verses now. Look at what verses 4 and 5 tell us. He counts the number of the stars. He calls them all by name. Not galaxies. He counts all the stars that are in all the galaxies. What kind of intelligence are we dealing with here? What kind of a being are we dealing with here? To you and I, this one grain of sand is mind-blowing, isn't it? Oh my goodness, look at that picture. Thousands in a grain of sand. It's incomprehensible. Off the charts. But Almighty God has a complete count of not just every galaxy, but every single star in every galaxy. He counts them all by name. He has names for them. All the names that He remembers. And this is why verse 5 concludes as it does. Great is our Lord, and mighty in power. His understanding is infinite. You know, we don't know who we're dealing with here, folks. We have no idea who we're dealing with. And what happens when a being like this determines, and he says something like, eye has not seen, neither ear heard, neither has entered into the heart of man the things this guy has prepared for those who love Him. And what about when it says that this guy here is storing up wrath against the day of wrath and the righteous judgment of God? Truly great, great is the Lord. But what is so curious about these two verses? 4 and 5. Remember, our text this morning is 2 to 6. This is 4 and 5. What is so curious about these two verses is where they appear in relation to the other verses that surround them. You would think verses 2 and 3, which precede this, on one side, and verse 6 on the other, would have something to do with God's power in creating, right? I mean, this clearly the context here is the stars and God's wisdom and His understanding and His power, all right? So clearly verses 2 and 3 and 6 are going to be about that too. Maybe about His sovereign rule over the earth, something that kind of relates to that. Maybe the way He controls the seas or the lightning or the storms. But they have nothing to do with that at all. Far from dealing with the majestic, transcendent issues of the heavens, they deal with the simple promises to the smallest, most insignificant people in the world. People like you and me. Let's look at this. Let's look at verse 2. The Lord builds up Jerusalem. He gathers together the outcasts of Israel. The same being who's got the grain of sand says, I am going to gather together the outcasts. Do you ever feel like you don't fit in? You ever feel like no matter where you go, nobody really gets you? You say, I work, but I don't feel like one of them. I'm in my family, but I don't feel like one of them. And to be honest, sometimes I go to church and I don't even feel like one of them. Do you feel like an outcast? Well, the God who put the grain of sand in the sky and all the grains of sand says, one day I'm going to gather you together. And I'm going to give you a place where you feel at home. Because you're going to be with me. That's verse 2. Go on verse 3. Let's look at this. It says, He heals the brokenhearted and binds up their wounds. Is your heart broken today? You know, sometimes I feel like I'm a man with full skin and bone, covering up a bunch of broken pieces. Some healing a little bit, some not healing. You got any wounds that just won't heal? Years ago, someone hurt you. Yesterday, someone hurt you. And your heart is broken. You lost someone that you love, that you needed, and you're hurting, and it won't go away. He heals the brokenhearted. This guy with the grain of sand heals the brokenhearted. And then verse 6, he says, He lifts up the humble. He casts the wicked to the ground. So he caps it off by promising all those who are oppressed that one day their oppressors will be thrown to the ground. You know something that oppresses me more than anything, maybe? It's temptation to sin. Does it hound you like it hounds me? Don't you wish you just didn't have the nature anymore? That I just could say no. Why, God, when I know this about you, why does it still tempt me? It oppresses me. It chases me all day long. And it runs me down and it smashes me and I give in and then it beats me again. The Lord lifts up the humble, the ones made small. And He lifts them up high. One day He's going to crush sin under your feet and you'll never have to deal with it again. But you may have noticed here, I'm pretty good at spotting holes in my slides. You notice there's a slot there between 3 and 6. You see that? A little hole there. Well, if you know me, you know I'm usually better than that. I don't let that kind of thing go on. Why did I leave the gap there? Because that's where the verses about the stars go. Right in the middle of all these promises to the people who are broken and down and hurting. That's where they are. They talk about His understanding and His power. Why are those verses in the middle? Why are they even there? Because He wants to remind you, outcasts. Because He wants to remind you, brokenhearted. Because He wants to remind you, oppressed, that the one who made these promises to you is the one who made all that stuff in that grain of sand. And He's the same one who made all the grains of sand. And 1,000,000 times more, He says to you, my little child, don't forget, I didn't just make one grain of sand. I made them all. And when I tell you I'm going to gather you together, I will gather you together. And there's nothing that can stop me. And when I tell you I will heal you, there is nothing that I cannot heal. And when I tell you I will break the bonds of those who oppress you, I will break their bonds. Amen. So what is your problem today? Cancer? An abusive husband? An unbelieving wife? A jerk of a boss? An empty bank account? Loneliness, depression, sorrow, Budweiser, meth, oxy, heroin. If thousands of galaxies and billions of stars are but a grain of sand to the one who lives beyond the heavens, how can the things that trouble you be too much for Him? What are you worried about, dear one? Trust in Him. Rely on Him. Wait for Him, because He counts the stars by number. He calls them all by name. Great is our Lord.